My name is Reza Rukui. I'm the Senior Director on SDN Application Architect at Sienna. Today's discussion will be about the coherent pluggables and how we are control and manage it from the IETF perspective. Before going through the presentation today, I will go through some basics, what problem we try to address, and after that, we narrow it down to exactly what it means that when we want to control and manage pluggable inside the various components, we will see, and what is the IETF activity at this time. You've seen so far there are various IETF activity. This is very specific in the area of the coherent pluggables. Before starting the discussion, I have to acknowledge the work that I am presenting here is a contribution of a group of operators and vendors at IETF. We came together, and whatever you see is basically the outcome of that discussion. It is still ongoing, and this is a very active subject at IETF. When we talk about coherent pluggable, let's start what it means. I have an IP network, I have two routers, there is an IP link in between. This is a logical entity that's connecting these two routers together. You're expert on that one. But when we talk about the IPoDWDM or coherent routing, it means that this overlay is sitting on top of an underlay. In reality, these two routers are not really connected together. They go through some transponder or muxponder through the ROADM for the photonic layer, and they are connected together. From discussion that we want to have, the important aspect is there is an optical or photonic services between two endpoints, and this mapping that you will see here is basically the important aspect. There is a mapping one-to-one, many-to-one, or one-to-many between services from the underlay layer 0 services and overlay IP. In other words, when you send IP link, think of an underlay services which is sitting there. Whether or not that underlay supports one or multiple IP links, this is something depends on the design. But this is very important implication as we go through the discussion, because each time that you see there is an IP link, something happened to IP link, you have to think about the underlay. That services that happens and everything under that. In most cases, or in some cases, we don't have all the equipment, muxponder, ROADMs, and everything, but think about that one from the logical perspective. Now, let's go one step further. I have the optical network as an underlay connecting two routers together. Now, if I take the transponder and the gray optics, put them inside an entity called pluggable. There are different names, coherent pluggable, plugs, optical pluggables. All of them are exactly the same. So now I have a router, same router. From the router perspective, it doesn't change the fact that I have IP link between router 1 and router 2. But from the physical connectivity now, instead of transponder, and I have that pluggable. Now you will see the pluggable physically goes to the router. And from that aspect, lots of things potentially will change. And we go through that one. But so far, I have two routers. Let's expand that one. If I have two routers that you will see here, we are not saying that remove all optical network from your, the optical equipment from your network and replace it with plugs. So we are saying that I have two routers connected through the pluggable to the photonic line system. It is possible that on the same network, you have router 3 and 4, same different IP link, but they are connected through expander, meaning muxponder or transponder through the ROADM. What is the meaning of this picture is trying to say that in a heterogeneous network, I have a combination of routers, optical line system, photonic optical pluggables, muxponders. In other words, everything is inside your network. And when we are talking about the automation, you have to think about a network which technically has all this together. This is, as we go through that, this has the important implication that you have to think about the way that you are controlling the network today. You are extending that network with pluggable tomorrow. And this is whatever we try to address as we go through this process. You will see momentarily what it means. So far, we talk about the pluggable and what it means and how it relates to the network. There is another aspect that you have to also think, because the whole theme of the presentation today is control and automation. When we talk about that, I have IP over DWDM network. At the same time, you have to think about various layers that resides from the underlay layer 0 all the way to layer 2.5, 3 IP MPLS. And this layering is not only for fulfillment or configuration, it is for telemetry collection, for PM, for alarm. So it's basically both ways, and you will see that this has, again, another implication for the control. When we want to control it, sometimes you don't want to do IP over DWDM and correlate under an overlay. It is possible sometimes this might be your use case. So from that aspect, your automation, the way that you automate the network is different when you want to introduce that. But important aspect of this one is multi-layer correlating underlay to overlay is very important. If you want to do it, again, there's a big if here, if you are interested to do that, you have to be conscious about how we are doing the automation from the IP network towards the optical network. So having this one as a background, there are various operational benefit that we can get from the multi-layer. Again, think about operational perspective, because today is about operation. So when you have that network that I introduced, I have pluggables, potentially there's a multi-layer connectivity or correlation between under and overlay. So to address various aspects of the operational benefit that we can have on that network, we define 5 different categories. I'm not going to talk about category 1 to 4. I just put it there as a completeness. We are going to talk about coherent pluggable lifecycle management. So basically, that last item is something that we are going to discuss. But there are more to it. If you are interested in any different aspect of the multi-layer IP over DWDM, the use cases that you will see here from the automation, assurance, correlation, and planning, we can have discussion. Please see me after the meeting. We can have a discussion. But today, we just talk about last category, which is the life cycle management of pluggable. So now we start from the pluggable itself. When we talk about the pluggable, it's an entity which goes to the router. We just discussed that. It has 2 sides. One side, or 2 personality. One side is optical photonic characteristic. You might heard about operational ID, media ID, depends on that you are familiar with this one from the, let's say, OIF perspective or not. These are various terms that you might heard about it. It's related to photonic side. What is the modulation I have to use? What is the baud rate? What is FEC? What is the rate that I use? What is different aspect of photonic and optical? And this one, in most cases, host, which is router, is not aware. As long as router is concerned, the port is 400 gig. Whether or not you use modulation A or B, it might not be that different or that important from the router perspective. The 400G should work, it's up and running, but this is the characteristic. As I will go through it, you will see what it means that host is not aware of that one. In most cases, it's not aware. We will talk about that media ID. Again, if you're familiar with that characteristic of this one is a media ID. It's a number that OIF or ITUT define to say OIF 0x3E means this group of attributes, basically characteristic of that interface. On the other side, now I have electrical connectivity of the pluggable to the router. This is electrical side. Again, if you're familiar with any of those SDOs, we call it host ID. Host ID is, again, a number that characterizes that interface. So obviously, host should be aware of that. If it is 400G, well, how many lanes I have? Those characteristics is defined from the electrical side on the router, on the connectivity between router and pluggable. Host ID, again, this is one number that characterizes that one, if similar to the media ID, which is for the other side. I will go through this one just for the completeness of our discussion. I'm sure if you are into pluggable, you heard about AppCell and other things, how they are really related to each other. And I try to simplify that concept. It might not be related to our discussion directly, but I think it's good to know the correlation between them. A coherent pluggable, as a general rule, supports multiple capabilities. It can support more than 3-4 capability. Each of these capabilities is defined with a number, and they are in a table. So basically, I have a table, capability 1, 2 to n. There is a pointer to that, and this one called AppCell. Again, if you heard about AppCell 1, 2, 3, 4, it is nothing but just a pointer. AppCell 2 means capability 2. You have to go through the capability 2 to see what it means. And each of these capabilities are 32-bit number. This is a characteristic, or this is the semantic of that one. Host ID and media ID is the most important aspect. So in this case, for example, AppCell 1 is pointing to host ID 1, media ID 1. And what the number is characterizing basically the behavior of pluggable. It's very similar to concept of the, let's say, routing policy. Instead of I define ACL on the router and say these are the 20 attributes, I say ACL 1, that means 20 attributes. Same thing here, media ID 1, media ID, for example, 0x3e means bunch of attributes. What is my the FEC, what is my baud rate, what's my modulation, and so forth. So, but suffice to say that the media ID is photonic layer, host ID is electrical layer. So this is the important aspect that we have to understand so far. Having that, let's go to one step further. I have a router, I have a pluggable. This is a portion of the network that we've seen so far. There might be, from the control perspective, again, the idea of this meeting, the theme of this meeting is control and automation. From the higher layer, there might be two different choices you will see on the left-hand side and the right-hand side. Whatever we are working on at IETF is basically, as you will see here on the picture on the right-hand side. It means that the characteristic from configuration or from the telemetry collection of the pluggable comes from northbound interface of a router. I cannot go and telnet to the pluggable and get something. So it is possible, but industry going towards the right-hand side. And this is whatever IETF is working on. Basically, everything is coming from northbound. If I want to expose something, it should be on northbound interface of the router. I have to have a Yang model to describe it. If it's a telemetry, I have to do the Yang push. I have to do the GNMI subscription and so forth. So whatever protocol you want to use, basically from northbound of the interface. That a small arrow that you will see on the right-hand side between the pluggable and the router, just for the completeness, it is the protocol which defined by the OIF, and I will talk about that momentarily, that basically characterizes how pluggable and router can talk to each other inside the router. We will talk about that shortly. Now, take the router and pluggable and blow it up. I zoom in inside this. I have a big rectangle, which is a router from vendor Z, from vendor Y. I have pluggable from vendor X and Y. So it's a basically multi-vendor environment. I have two plugs from two different vendors inside the router. All these boxes that you see here, I put here, these are functional boxes. We are not saying that there are different boxes inside the router. These are just functional blocks. There are some functional blocks from the router side, and there are some functional blocks from the pluggable side. What we're trying to convey with this picture is there is a router, there is a northbound interface of the router, all the control logic, it IP or optical or multi-layer, we talk about that momentarily. The controller is on northbound interface of a router. And there are two aspects here. This is basically describing multi-vendor concept and also the concept of the host side and electrical side inside the pluggables. Take the same picture. If you are familiar with the CMIS protocol, it's describing the connectivity or the protocol that is running between pluggable and host. It's inside the router. So basically, CMIS OIF is a protocol which defines how pluggable and router can talk to each other. Whereas the IETF, which exposes the northbound interface of this one, is addressing the network-wide perspective of this router connected to another router, and potentially we are going to create an layer 0 service between two pluggables and bring an IP link that we discussed at the beginning on top of it. So IETF perspective is describing how to model everything from the northbound, from the network perspective, whereas OIF talk about perspective of the pluggable and router from the node perspective. But having said that, it should be very important to understand that these two should work together. I cannot have independent CMIS and independent IETF. They have to work together if we want to go to real plug and play mode that we are try to address. So this is one thing that it's important, and we try to promote that at IETF, that these two organizations which are designing and describing various characteristics of this protocol should work together to have a real, workable, pragmatic approach for control and management of pluggables inside the router. So now going through the detail of the pluggables, because we want to talk about automation from the pluggable perspective. From the pluggable itself, there are various building blocks. You will see here on the right-hand side is the media, on the left-hand side is host. We just established the fact that there is the optical photonic on the right-hand side, electrical side on the left-hand side. These are logical boxes that has characteristic of exactly photonic, optical, and electrical. And taking this one to the consideration that when we want to do the modeling of this one from the IETF perspective, we consider these different building blocks. In most cases, we talk about the right-hand side, which is the photonic aspect. There are some implications on the left-hand side, for example, for PM and alarm and so forth. But these are the building blocks that we are going to consider. Some of them are really related to the work that we do for the manage and the modeling of that. Some of them are less, but these are the 4 blocks, or actually 5 blocks, if you consider the equipment as a block which is covering everything. There are 2 work happening at IETF right now. One is vendor-driven, one is operator-driven. The first one that I'm showing here is the vendor-driven. So we are going to address the modeling from the Yang perspective, what should be there. And we are trying to not reinvent the wheel. In other words, we are going to work with existing model that is there in various STOs, IETF, OpenConfig, TAPI, OIF, and others, ITUT. We try to go through all those to say what is needed to be included, and from that aspect is giving a concept that is putting all this together. If there are something that any of these STO are working right now, and it's good to have as a general pluggable characteristic that should be exposed to the northbound interface, we are going to use that. There is a link to the draft. You can take a look. If you are interested to be part of this activity, by all means, as mentioned before in the previous IETF, IETF is very open. You can come and contribute as much as you want. You can just contribute, just passively look at it and see what is going on, or you can be on the other spectrum to be proactively contributing to that. But this is something that we feel is important. We want to be pragmatic. We don't want to be realistic. We want to be realistic. We don't want to do something that it takes a few years to complete. We want to come up with something that we know is importance of this one, and we want to make sure that we can address it. And as we go through the process, we are going to refine it. So this refinement of this one is going to happen, but this is very important aspect of that. On the other side, there is another IETF draft, which is driven by various operators. And that one is going to cover the use cases. Forget about how it is modeled. We want to see whether or not I can go and address various operator use cases. So what is the expectation from operators? Starting from discovery of pluggables. We assume all the times when we talk about something, the pluggable is there, everybody can see it, so let's go and configure it. Let's go and collect the telemetry. But this is, in some cases, not even right assumption because the pluggable is not discovered yet. So the whole idea of discovering the pluggable, discovering inventory of that, discovering layer 0 service, just a read-only. Whatever I have, I discover everything from layer 0 all the way to layer 3, anything related to that. And the other use cases that they want to address, now I'm going to go collect the PMs from the multi-layer, configure layer 0 service, bring IP, the link, create IP services, TE tunnel, SR policy, L2, L3 VPN on top of that. So these are the various use cases. And if you are familiar with telecom infra project team, whatever they put here is aligned with that initiative as well. Again, that is some project which is driven by the operators to address various aspects. One of the aspects is related to IPoDWDM and in specific about the pluggables. And these are the activity that's happening right now. And going one step further, we talk about routers, plug itself, two activity happening. Now, if I go one step higher, what about the controller layer? So when we talk about the control of the pluggables, we have to consider this cloud. I expand that cloud. I put IP control. I didn't put IP controller. There is a very clear reason that I put it there. Same thing for optical control and higher layer control. The boxes that you hear, these are functional boxes. We are saying that there should be an entity called IP control to address end-to-end IP visibility, lifecycle management of IP from planning, creation, automation, all the way to collection of PM and optimization. Same thing for the optical. We are saying that there should be an entity to address planning of the layer 0 services from plugs to plugs, automation of that, assurance, telemetry collection, and so forth. And if you are interested to do multi-layer, you have to connect or correlate IP information to optical. You will see it's a higher layer. This is the reason that we have 3 blocks. This block is not implying that how you want to realize or implement it in the network. We will go through a few examples, but this is very important. If I show you this picture without the context, you think that this is the way that I'm saying that go and control your the network. But this is not the case. Here is a very important aspect that we have to consider. And for the sake of our discussion from the photonic and optical side, we have to consider everything from plug to plug or from transparent to transparent. Depends on what situation you have, from planning to validation to automation to collection of telemetry and all the way to optimization. There are potential many different ways that you can realize the previous picture. This is just 2 examples of various things we can do. Now I have realized this one, this blue boxes, now they are realization. They are controller. In the previous one, I have, on the left-hand side, I have 3 boxes from different vendors, which is IP controller, photonic layer controller, and multi-layer. On the right-hand side, there is 1 box which is doing all this. Now these are realization or implementation. And you can imagine that any combination of this might be valid, depends on your use case, depends on your the way that you want to do it. Maybe right now you don't have any higher layer control or orchestration in your network. So when you go to pluggable, maybe one aspect, one realization is better than others. And this is the important aspect to consider when we talk about the control and management of this network. Also think about this network not only pluggable, that the heterogeneous network that we defined or discussed before. If this network also has transponder at the same time, you are creating services on top of transponders, not only pluggable, you have to consider that fact. But suffice to say that the implication of this one here is that we need, from the optical or photonic, same thing for IP and multilayer, you need a single logical functional entity to address all aspects of the life cycle of that one. And this is the important aspect to consider. And to conclude the discussion, the few slides that you will see here, this is the work that started at IETF, how to address that controller layer. So they are on hold at this time. There are some activity I will show you, but depends on the result of the previous draft. We are going to continue this one. But I put this one just for the completeness of the discussion. Take that control layer that I just discussed. There are potentially few options to realize that network. And that one depends on your use case. We are not saying which option is better than what. There is no, all of them are valid. These are the tools in your toolbox. Depends on what you want to do. Some of them might be relevant to you. So the first option is, as you will clearly see here, now they are controller. You will see packet controller, optical controller. They are controllers. So from that aspect, look at the optical network and optical controller. We are saying that pluggable information from the telemetry goes directly to the photonic controller or optical controller, but other information for the read write should go through IP and orchestration layer, because this is the only way that they can do it. This is the draft that you will see. You can go through it to see pros and cons and why this is the case. Another thing is, you can simply go the simplest way. So whatever is inside router, one controller, whatever is not is another controller. I don't care, it's IP or optical. This might be, again, valid for some scenarios, but the implication of this one is, if I want to create the optical service from plugs to plugs, I have to send it to the optical controller. Some portion of that should go to the higher layer, come to the IP. So you will see the problem here, or the realistic view of this one here, is that all these should really work together. There should be a coordination. So again, you can look at your network to see which one makes sense to you. There is third option, which is combining those together. We say that optical controller is responsible for everything optical, regardless of physically is outside router or inside router. If I have a transponder, this picture is valid. Transponder creates service layer 0 from one point to another, from planning, viability, creation, and telemetry collection. Same thing here. But the point here is, there might be option 4, 5, 6, going forward. You can combine this as a food for thought. Why we don't have east-west relationship or connectivity between two controllers? They can talk to each other. This might be an option, might be valid, but this is the whole idea of taking these options as just options. These are valid, depends on your scenario. Some of them are valid. But the work that we are doing at IETF is going to continue. This is the initial work. You will see the draft. If you go take a look at the draft, there are references there. And the whole idea of this chart here is to just give you a perspective, to look at that from the perspective of your use case. And depends on that, some of these options is more valuable or valid to you than others. So what are the key takeaways? It's standard policy. IETF is working on this. There are a group of operators and vendors. about how to do the plug and play, how to control pluggable inside the router. There are work that we are doing at IETF. It should work with OIF, so there should be a liaison between them. These are the activities that are happening right now at the standardization body. Operator-driven use cases, there is one draft that I mentioned. They are addressing various aspects of the operator side. Another aspect is the vendor side. Now, I know what the use case is, how I'm going to use it inside my network. I have to have the Yang model. I have to do the model-driven aspect, how I'm going to do it. And last but not least is the next step for all this is putting this one together with the controller that I mentioned, put it together. We want to have a realistic and pragmatic approach to that, and this is understandable by all community at IETF, and this is the next step that we do. With this one, we are concluding the session here. I see 3-0 here, and if there is any question, I guess we can take a couple. So no question means either very good, or not clear. So I hope it's a format. And with that one, you're good to go for end of the day. Thank you very much again. And if there is any question, we can have a discussion after the session. Thanks again.